Hello and welcome back for the last time in this class. We are going to talk about U substitution again, except this time I am going to use U substitution on definite integrals. Definite integrals are those that have limits, lower limit, upper limit, and you compute with the fundamental theorem of calculus part 1. So just a quick review of what was the definite integral. Definite integral had limits, let's say 1 to 3 for x squared dx, and then you integrated first between 1 and 3, which will give you 3 cubed over 3 minus 1 cubed over 3, which is 9, minus 1/3, which is 8 2/3. So this is what the definite integral was. So now say that I have integral of, say, square root of 3x plus 1 from 3 to 8. I just put whatever, dx. We know that this integral has to be solved using U sub, but the crucial thing to remember here is that these are x1 and x2. These are the limits on x-axis, your a and b. The function is in terms of x, and then you have dx. So all variables are x in this particular problem. So now, if I swap and say u equals 3x plus 1, where du is 3dx, I am swapping my, right, I need a 3 and a 1/3, right? I am swapping the variables from x's to u's, which means that these limits that used to be x1 equals 3 and x2 equals 8 are no longer good because those were x limits. But all of my variables switched to u, therefore those limits have to switch to u as well. It's very simple. I'm just going to use the u sub equation to do that, but you have to remember to do it. So u1, which is the lower limit, is going to be 3 times 3 plus 1, which is 10. So the lower limit is 10. 3 changed into 10. u2 is the top portion, top limit, which is 8. So it is 3 times 8 plus 1, which is 25. So the upper limit is 25. The great thing about this is once you integrate, you do not have to go back to x, because your limits are now also in u, and whatever you get, you just compute. So there is no going back to x when you have a definite integral. We are not going to put plus c. Three and 3 will cancel. Oh no, 3 and 3, that will make 2 over 9. That's 2 over 9. We have 25 raised to 3/2 minus 10 raised to 3/2. Now you can use the calculator to get the number out of this. No one cares. So this is the u sub done on a definite integral, and we changed not only variable x to u, but we also changed the limits, which are x's, to u's. If you are still pondering why, remember that the integral a to b f of x dx gives you area if the function doesn't dip below x-axis. So if I have something like this from a to b, this is the area we're talking about. Observe that this a is your x1 and your b is the x2. They're both x values, those a and b. So that's why when you swap x value, x variable for u, you swap dx for du, you must swap limits from u to from x to u, and you do that by simply plugging those values one at a time in your u substitution equation, whatever it is. So that's why you have to switch the limits as well. Now someone is bound to ask me eventually, do we really have to change limits? Because if we integrate using u sub and then go back to x, can we use x limits? The answer is yes. You can skip the whole limits conversion thing, do the u sub for the integral, solve the integral, and then put back this and use old limits. However, I found that to be a bad practice because in the heat of the exam and everything, as soon as you see one or two steps where you didn't put the limits, you just forget about them. And by the end, you did the problem. You, instead of computing a number, you put plus c, and obviously it's incomplete. So, and it would be wrong to put 3 and 8 here, because it's not 3 and 8. So I always suggest learn a very simple step, which is always a very basic arithmetic. Use the u sub equation, whatever it is. Sometimes it's sine and cosine, sometimes it's to change these guys into the actual limits for u, and then you don't have to go back to x, you just compute from u. So let's do another example. I know I want to have this so far. Yeah, whatever. Here, have fun. What is u? Du? 2x dx. Good. So you see that you can write this 4 as 2 times 2, right? So we kick one of the 2's outside. And what do we get? Very good. What are the limits? u1, we plug 2 squared plus 1 is 5. And u2 is? Anyone? Very good. 2 ln u from 5 to 10, which is equal to 2 ln 10 minus ln 5 2 ln 10 over 5 to ln 2. Properties of logs. Chapter 3 in the Blitzer book, Precalculus 1. Subtractional logs equals the log of the division of the quotient of the arguments. One problem from the textbook, and then we'll talk more about the final exam. The textbook example 75. Integral from negative pi to 0 sine x divided by 2 plus cosine x dx. 20 seconds, no pressure. Go.
All right, let's take a look at the solution for this problem.
U equals what? Very good. And du is? Nice. Now, we transform our limits. U1 is 2 plus cosine of negative pi. How much is cosine of negative pi? Well, it's the same as cosine of pi. And how much is cosine of pi? Very good. So the lower limit is going to be 1. Upper limit is 2 plus cosine of 0. How much cosine of 0? Very good. So we have our limits to be 1 to 3 of what? Negative? Negative du over u. Very good. So that will be negative ln absolute u from 1 to 3, which is negative ln 3 plus ln 1. This one goes to 0. So ln of 1/3. You can also leave it as minus ln 3 if you want to. Or ln of 1/3, whatever makes you happy. It's very important. It's calculus class. Important for you to be happy. All right, so that's U sub with changing limits. I'm going to stop the stream. Bye, stream.